Welcome everyone. So let me take another doubt today. So over the years, I have found generally 12th class students they find this thing to be most confusing to them. Lenz's law. So this Lenz's law is basically used to find out the direction of induced EMF in any loop through which the magnetic flux is changing. Basically, students they get confused between direction of magnetic flux and change of magnetic flux. So I have found two confusions here. So one confusion is that students, when they remember this statement, they just memorize it as if they are memorizing some Sanskrit verse or as if they are memorizing some statement written in a foreign language. It's like if you ask them, then they can recite this statement very fast. What is Lenz's law? Lenz's law states that the direction of induced EMF is such that it opposes the cause that is producing it, but they don't understand it what they have just pronounced. So this is the first thing which I have found with students, that it's like, if you ask me to recite some Sanskrit shloka, I can recite some Sanskrit shloka. If I write that Sanskrit shloka in English and tell you to recite, you can read it, but does that mean you have understood the meaning of that Sanskrit words? No. I have found the same problem with students. When it comes to this statement, they mug up this statement and they recite it so fast, but they just don't know what it means to them. So this is the confusion which I have found, and I am here to help. So let's understand it. How to find direction of induced EMF in these cases? I will be taking this for example. These are four loops. They are placed in magnetic field, and I have taken all possible cases here. So here the magnetic field is inwards and it is going to increase with time. Here also the magnetic field is inward, it is going to decrease with time. Here the magnetic field is outward and it is going to increase with time. Here the magnetic field is outward and it is going to decrease with time. So all the four cases are covered, and how to find the direction of induced EMF in all these cases. So let's understand the statement. So the statement, Lenz's law states that the direction of induced EMF or induced current is such that it opposes the cause that is producing it. So cause that is producing it, this phrase refers to the change of flux. Change of flux is the cause which produces induced EMF. Faraday's law states that if you have a coil and if there is magnetic flux linked with that coil, and if that magnetic flux is changing with time, then only there will be induced EMF. If the magnetic flux remains constant with time, then there is no induced EMF. So this is also one of the misconceptions. People think flux produces induced current. No, flux doesn't produce induced current. It is change of flux which produces induced current. A constant flux doesn't produce induced current, right? So that's what Faraday's law talks. And Faraday's law is self-sufficient. EMF equal to minus d phi by dt. From there also you can find out the direction of induced EMF, but still without doing calculation, logically if we want to find out the direction of induced EMF, then Lenz's law helps us in that. So it is not, first point, it is not flux which produces induced current, it is change of flux which produces induced current. By change I mean either the flux would be increasing or the flux would be decreasing. If the flux remains constant, then it doesn't produce induced EMF. So now, as per this law, the direction of induced current is such that it opposes a change in flux. That means if flux is increasing somewhere, like here, then the induced current will be such that it will try to oppose that increase. If the flux is decreasing somewhere, these are the cases, then the direction of induced current or induced EMF will be such that it will try to oppose that decrease. So what is getting opposed here? It is not the direction of field, or it is not the direction of flux which is getting opposed here. It is the increase or decrease which gets opposed. So the misconception, generally students they think the misconception that induced EMF is such that it opposes the flux. So as per the misconception, how will be the answer? So as per the misconception, स्टूडेंट्स का आंसर ये होगा, यहाँ पे फ्लक्स अंदर है तो इंड्यूस करंट बाहर होगा, ऐसा। यहाँ पे फ्लक्स अंदर है तो इंड्यूस करंट बाहर होगा, ऐसा। सो दीज आर द आंसर्स एज पर द मिसकंसेप्शन। राइट। बच्चों का मिसकंसेप्शन है कि उन्हें फ्लक्स अंदर है तो बाहर होगा इंड्यूस करंट, अपोजिंग टू दैट फ्लक्स अंदर है तो उसको अपोज करता हुआ बाहर होगा इंड्यूस करंट। यहाँ पे फ्लक्स बाहर है तो उसको अपोज करता हुआ अंदर होगा इंड्यूस करंट इस तरफ। यहाँ पे फ्लक्स बाहर है तो उसको अपोज करता हुआ अंदर की तरफ होगा इंड्यूस करंट, राइट। अंदर मीन्स लाइक दिस, so it is like this. Bahar means I have to take my right hand and I have to hold it like this. So this is how the direction of current flows. So the common mistake is they try to oppose the direction of flux. Their logic is यहाँ पे flux inwards तो outward कर दो induce current को, यहाँ पे flux outward तो inward कर लो induce current को। यही है misconception. So you don't have to, or the Lenz's law or the induced current, it doesn't oppose the field, it opposes the increasing in flux or the decreasing in flux. So the right answer would be, okay, let the wrong answer stay here in black ink and let me write down the right answers in blue ink so that you can compare. I want to compare the misconception with conception. Sometimes misconception also can give you right answer. So let us compare. So here now we have given the direction as per the misconception, and then now I will write down the answer as per the right concept, and then you will see that a person having misconception can 50% times get correct answer. That doesn't make the misconception right. Even a clock which has stopped working can show right time 2 times daily. Think of a clock whose battery is over, right? Its battery has been completely discharged, battery is no more working, the clock is stopped, but still it can show correct time twice during a day, isn't it? Similarly, while applying misconception also, sometimes you can get right answer. That doesn't make the misconception right. That's what I want to show here, that now we have applied misconception and we have found the answer. Now let me apply the concept, the right concept, and find the answer. So the right concept is, here the flux is inwards and it is increasing. So it is increasing inwards. Induced current or induced EMF wants to oppose this increase. Therefore, the induced EMF or induced current will be outward. Therefore, it is clockwise. So the right answer here will be like this. Oh, here, even a person with misconception get right answer. Now coming to this. Here, the flux is inwards and it is decreasing. So the flux is inwards and decreasing. So the induced EMF or induced current won't allow it to decrease. That means it opposes that decrease. So it will produce flux in this direction. So if the induced EMF has to produce flux in this direction, then it has to be the induced current has to be like this, right? So here the answer will be like this. The induced current will flow like this. Here it was induced current will flow like this. So you see, a person having misconception can get right 50% of the times. Okay, now let's come to this. Here the flux is outward and increasing. So induced current or induced EMF will oppose that increase. That means it will be inwards. So the induced EMF or induced current will be like this, clockwise. Here the flux is outward and it is decreasing. So now the induced EMF or current will oppose this decrease. That means it would like to produce flux in this direction. So now the induced current wants to produce flux in this direction. So it has to be in this way. So the right answers are the blue ones. The blue ones. And that the black color answers, black color arrows, what you have got, those are as per the misconception. So even when you apply misconception, 50% of the time you can be right. That doesn't make the misconception right. Hope I have made this clear. So if you have any further questions related to this, or if you have any new questions, you can always ask me either by commenting below or by sending your question to the WhatsApp. Now if this video has helped you, then please subscribe to my channel and share this amongst your friends. Thank you.